Now, when most people think of the internet, they think of the World Wide Web or web. Now, in reality, the internet is much larger than just the web. It's composed of a variety of different types of tools and protocols, everything from email, which we're also familiar with, although we might view it through a web browser, and most modern online services like Gmail and Yahoo and things like that. We could also think of it, however, as things like Gopher, which you might not have ever heard of before, and some other protocols and tools that are not used as much, mostly because the web has replaced them as something that's easier to use. So we're going to focus on the web in this course. And so let's talk a little bit about its history, though, just real quickly so we understand where we're coming from so we can understand where we're going to go. Now, the idea for the web came out in about 1989. Tim Berners-Lee, he came up with this idea and wrote a paper while he was working at CERN. A few years later, he wrote the actual first source code and released it into public. So depending upon who you look at, is it the idea or was it when the source code was released, you'd be looking at late 80s, 1989 to early 90s, 1993 for when the web was created. Now, a lot has changed from that time. A lot of the changes are actually because of things like your personal computer getting much, much faster and able to do so much more. Back then, the original web, in many cases, they didn't support images, and they might have, but not everyone could have viewed them, and there was text-only web browsers that didn't have images, which you might think is kind of weird, but is very real. They didn't have audio or video for sure. And most people didn't even have a personal computer back then, and no one had a cell phone that could view the web. So the web was very, very limited, and the original HTML specs were not as robust as they are now. In fact, the web could be kind of viewed as a wild, wild west as far as standards and specifications. With HTML3, which was probably the biggest HTML spec that came out and was the one that was most widely adopted in the late 90s, there was still a lot of things that could be added to it, and so browsers were working very hard at trying to one-up one another. Netscape was one of the leading browsers at the time, and they gave away their browser for free. It was kind of an interesting idea. Free software was a relatively new concept back then. Most software you had to purchase. And I remember walking into a computer store back when there were computer stores you could walk into, and you could find some browsers on the shelf and they'd be 15 or 20 bucks. Yet Netscape you could go and get for free. And you might say, well, why were they doing that? How did they make their money? Well, Netscape also sold web servers. And they knew that without people having a web client, there would be no need for web servers. So they wanted everyone to have as many clients as possible. During the late 90s and early 2000s was the great browser war between Internet Explorer and Netscape. Internet Explorer finally won that war, and it became the standard. However, in that time, both browsers would add new tags to the specification that were not technically part of it. They would try to get developers to use these tags in order to require people to therefore use their browser. And that's kind of how the browser wars were. This continued through the HTML spec 4. And this caused a lot of problems with web developers. Web developers were very frustrated. Testing between multiple browsers that behaved very differently was time-consuming, frustrating, etc. So the xHTML spec came out, and the idea was it was written by programmers, and they said, hey, we know how to write specifications. We're going to be very precise. The problem was because xHTML was so specific, if you weren't a programmer, it was very difficult to write. It was based off the XML specification, which we're not going to get into at this point, but it's based off the XML specification and had lots and lots of rules. The xHTML specification was so stringent, it was expected that 98% of all web pages had one or more errors. And so the browsers had to know, well, this is the specification, but they became very good at trying to figure out what did the author of that web page intend. And if it intended something, it could try to go through and make it work correctly. Now, part of the ability to solve these problems as the web page was being drawn, in fact, HTML is hypertext markup language. And what that means is it was simply taking text and it was changing the way that it looked. It was grouping things together. It was emphasizing certain things, etc. That makes it a little bit easier to solve problems automatically than in a language like C++ or Java or something like that. So xHTML and HTML4 was used for a long time, but people were still frustrated with it. xHTML is a little bit verbose, it wasn't real easy, and it was very inflexible. It was hard to update, and as computers were getting faster and faster and faster, and as the mobile devices started coming out and tablets started coming out, we wanted ways that we could incorporate multiple different types of devices and all that new power and speed that's available. And xHTML, it didn't do that. So what we wanted to do is we wanted to say, hey, how can we solve this problem? And they came out with the HTML5 specification. And they did a couple of really interesting things with HTML5. The first thing that they did was they made it a living specification. Now, what that means is that HTML5, they have different groups that work within it, and they said, you know what? We are going to know that specifications need to change. So instead of having 5 and then 5.1, and oh, well, this is a big update, let's do 5.5, they just say, you know what? HTML5 is the current specification, and it's going to constantly be changing. So when they create HTML5, they put in things for audio and video, but it's also left open so that if the next technology that comes out does so, it might be able to support it. What is the technology going to be? Who knows? It might be some sort of augmented reality component. So if you're using something like an Oculus or some other VR type of tool, you can look around and maybe have data that comes up and displays with it. Maybe it's going to be some other format. We don't know. But the specification does change from time to time, adding new features. The second thing they did, which was really nice, is they simplified the format. And that was a huge thing because instead of it being so rigid and strict like xHTML, this became a lot easier for people to write these HTML editors and even have web pages that can build web pages. And if you look at a tool like Wix, for example, they're a good example of a web page that helps you build web pages. There's other tools out there like that as well. And so you can use something like that. The final thing that they did was something that was actually very technical that a lot of people didn't realize, but it was a smart thing to do. And HTML5 said, you know what? We are a markup language. We are not saying how something looks. And so there have been a lot of kind of cross-pollination between how a page was structured and how the page looks. And so they said, we want to completely separate those, and this is going to give a lot more flexibility. And this comes from the idea of actually programming. If you've worked with any multi-tiered programming languages, you're going to see this. This would be things like, for example, if I have a 3-tier system where I store my information in one place and I present it in another, and then I have logic to control it as my 3rd tier. Well, HTML was designed around that concept. And so they said, well, we're going to have the web page. This is going to be like our data. This is going to be the information. And if I have nothing else, my web page should still look and work the correct way. Then we're going to have CSS, and specifically CSS version 3. And it's going to control how the web page looks. And so we're going to meld these two as a union. And with that, we are going to now be able to display web pages. Finally, the interaction, that's going to occur with JavaScript. And JavaScript is going to be able to work directly with the web page, and we're going to be able to use information from the web page and the CSS. So the three of them together create a unified experience. And this has allowed us to do a lot of new things that weren't previously capable. They've expanded what JavaScript can do, so it's a lot more efficient, as well as making it easier for both JavaScript and front-end developers. So let's just talk about a couple of quick terminology things so that we're all on the exact same page when we're working through a class. Because we want to make sure that if I say one word, you're thinking the same meaning and vice versa. So when we talk about a web page, we're talking about a single page on potentially a much larger site. A web page is going to use the HTML specification. It will quite possibly import your CSS and possibly JavaScript as well. Technically, the CSS and JavaScript are not required. So the file extension for a web page is going to be .htm or .html. Most web servers are case sensitive. I personally recommend using your file names to be all lowercase. This makes it much more consistent and likely for you to find it. So when you go and create a link to another web page, it knows where it is. If you mix and match and do uppercase and lowercase and whatnot, it might work on your local machine, especially if you have a Windows machine, but when you go to push it up to a server, it will not. So I found that recommendation of being all lowercase to work really well. It simplifies everything. On a dynamic web page, you might have HTML mixed in with this other programming language, and this programming language can generate HTML. So this is a little bit more complicated. It's how most modern e-commerce stores, content management systems, blogs, etc. are all done, however. We're not going to cover dynamic web pages in this class. That's okay. We have to have a good foundation first. There's another class that follows this where we do talk specifically about dynamic web pages and how to create and use them. Because they're using different languages, they may have different extensions. And you might see it as like a .php or some other extension like that. So if you've ever wondered, hey, why is that different when you're browsing the web? That is the reason why. When the dynamic page is finished, what we call rendering or generating on the document, it should spit out a HTML document to your browser. And this is how your web browser can quickly and easily understand it. Yes, it was generated dynamically, but it generates HTML code. Now, one of the interesting things about dynamic web pages is because it's dynamic, it can generate different results depending upon who's viewing it. Think about if you go to Instagram or Facebook, Amazon, you log in, you view it, your friend logs in the computer right next to it, they view it. Those are both very different results. With an e-commerce store like Amazon, they're looking at what have you recently purchased? What have you previously purchased? Have you purchased something that needs to be used and you might need to reorder? They're looking at hot items right now that are being sold, and they're going to present all those types of information to you. On a social media page like Instagram or Facebook or any of those types of pages, it's going to look at who do you follow, and based upon who you follow, they're going to look at what is popular, and it's going to try to show you the popular post based upon what you follow. And it may even have algorithms in there that say, hey, this is someone you don't follow that maybe you want to. So while you both go to the exact same location, because you're different users, the end results and what's sent to your browser is very, very different. Now, if a web page is a single page, what is a website? Well, a website is a collection of web pages. They may be dynamic, they may be static, they may be mixed. So a website is typically revolving around a single theme. It's going to typically have a single domain. So if you go to xyz.com, that is your web domain. The entire thing underneath it is a site. Now, some sites are very large and have thousands of pages associated with them. Other websites are very small, and you can have a website that only has a single page. In fact, this is becoming a little bit more popular in some modern circles. Not completely, but it is available to you. Often what happens in a case like that is it is a dynamically driven site, and that information is hidden from you. It displays what is necessary. So your website can have one page, it can have many pages, typically revolves around a single theme, whether it's a company, a person, a topic, etc. You have websites on the internet, and the internet is publicly facing. Well, you can also have privately facing websites. That's called an intranet. An intranet is going to be something that is inwardly facing. Maybe it's for a company. You have to be logged into their network, maybe on their physical location, in order to access it. And it might have things such as HR documents and forms and other things that might be considered proprietary information. And since it's only really useful for employees or students maybe of that location, they have security which keeps it from going out to the internet, and thus it's intra or internal network. So that's what an intranet is. Now finally, we've talked about dynamic web pages. I want to specify what is a web application. Web applications are generally built up of dynamic web pages. That's right, usually more than one. These pages will once again work around a specific theme. It's a theme of the site that dictates what is the application. It may be a content management system. It may be a blog. It may be some sort of online auction or e-commerce type of store. These are performing a task. They almost always have to have some sort of back-end database driven power. That's going to be where it's pulling information from. They almost always have to have some way to access that information and control it. And so your web application is going to be the dynamic web pages and any associated files with that. This could be as simple as a blog, which just displays information which someone writes out in a chronological order, or it could be extremely complicated. Now, in some cases, you can have multiple applications running on a single server. For example, WordPress. It's a simple web application. You can put multiple instances on a single web server. I have myself in many cases. You also have more complicated web applications that, in fact, need multiple computers to run. I used to work for a company and they were working on a web interface for their application. Their application was so complicated it took a minimum of 3 computers in order to properly run it. Now, it was doing a lot more processing and had a lot more logic and data than your typical web page, which is why you needed 3 computers to run it. But in turn, if you look at a website like Google or Facebook or one of those types of applications, you'll see that they don't run on 3 computers, but they run on thousands of computers. And if you do a little bit of background checking, you can see where they have huge rows and rows and rows and columns high of computers. And they have multiple buildings like this spread out throughout not only the United States, but throughout the world. So it's a very interesting concept to look at. How do these work? That is clearly beyond the scope of what we're going to talk about in this class. So you don't have to worry about figuring out how am I going to learn how to manage to program thousands of computers simultaneously. Don't worry about it. No single person there does it either. They have groups and teams of teams of teams that do that. We're going to be focusing first on building those single web pages, building them into a website, and going from there.